Hi guys, in today's video, we are going to be talking about how to convert from a chemical formula to find the percent composition of that compound. And so what we mean by that is it's often helpful to know the percent composition of a material. So if I were to hand you some jeans, if you wanted to predict how comfortable those jeans would be, it would be useful to know that they were 98% cotton and 2% spandex. Adding spandex to jeans made them a lot more comfortable. If you've ever worn jeans without any spandex in them, they're quite rigid. As we get more and more spandex, you move from jeans to jeggings, like pajama jeans. And so as you move through that, you're decreasing the amount of cotton and you're increasing the amount of spandex. So as you change the composition of the material, we can predict how comfortable that material will be. The same thing is true in chemical formulas. So as we do the percent composition and we find out, for example, how much carbon, what percentage of carbon dioxide is carbon, or what percentage of water is hydrogen, we can find out more and more things about those chemicals. We can make more predictions. So it's a useful thing to be able to do, and today we're going to learn how to do it. We will be starting with one simple problem that says calculate the percent composition of CO2. So we are finding the percent composition of CO2. Of CO2, we would start by identifying its molar mass. We have been taking molar mass since the beginning of this chapter, so hopefully this is something that is really easy for you. So the first thing we want to do is write out the molar mass the way we started doing it with all of the component pieces. So we start with carbon and oxygen. Based on the formula, I have 1 carbon and 2 oxygens. I want to multiply each by their molar mass. Using the periodic table to get the molar mass, carbon's molar mass is 12.01. And oxygen's molar mass is 16.00. Now we can finish out that problem. We get 12.01 plus 32, and that gives us the molar mass of carbon dioxide. So step 1, find the molar mass. That's done. The next thing we need to do is find out if the whole mass is 44.01, what part of the mass was contributed by 12.01? So this is similar to figuring out how you did on a test. Let's say that you got 13 right and there were 20 possible. In order to figure out your score, you would do 13 divided by 20 because that would tell you the part that you got correct on the test. You got 13 out of 20, or 65% right. In order to find that percentage, what you're doing is we are dividing the part, 13 that you got correct, by the whole, the 20 that were possible, and multiplying by 100 in order to get your percent. So we're going to apply the same concept up here. So the part that we're learning that is new is that we're going to take this 12.01 and we're going to divide by 44.01. So this is the part here, and 44.01 is the whole. And then I'm going to multiply by 100 to get the percent. And so what I'm going to plug in here is 12.01 divided by 44.01, and we're going to get 0.2728. Now, you guys know that you can probably multiply that by 100 in your own head, but we would get 27%. Remember, that's already 2 decimal places, so we don't do decimal places on percentages. 27% carbon. And now if I wanted to figure it out for oxygen, I would also divide by 44.01 and times 100. So again, now I'm going to do 32 divided by 44.01. And then I could again multiply that by 100, or I can just move the decimal place over in my mind, and I get 73% oxygen. Now, the last thing we want to do here is we want to check our answer, because whenever checking our answer is as easy as adding, we should absolutely do it. This should give me 100%. If I have done this right, then I'm going to have 100% because everything should be made of either carbon or oxygen. So what this is telling me is in a single carbon dioxide molecule, 27% of the mass of that molecule is made from carbon and 73% of the molecule is made from oxygen. The next thing we're going to do is actually take this and work backwards. So when we're taking this and working backwards, we're going to take the percent composition and work our way back to find out this original formula. So for our next problem, you are going to be given things like 27 and 73%, and you're going to be asked to find this number at the end. I call this one doing a magic trick. He's kind of found the part of going from percent to empirical formula to feel a little bit like you're doing magic. As we're going through this problem, especially this first one, you're going to be doing things and you're going to be like, I just don't know why we're doing this. What are we going to find out? And at the very end, we're going to get a series of numbers. And then bam, that series of numbers is going to make a formula. And it's usually a formula that you remember or are familiar with. And it's like, whoa, how did I do that? So follow along, write it down as we go, but know that after the first time you've gone through this percent to empirical formula calculation, the subsequent times that you go through the same process, everything will seem a little easier because you'll know where we're going with it. Okay, so just bear with me and get through this problem with me. So in a problem like this, you will be given a question that has percentages. This question says, what is the empirical formula for a substance that is 11.2% hydrogen and 88% oxygen? In order to solve this problem, the first thing we need to do is change our percent to grams. That is the easiest to do if you assume 100 grams, and I want to show you why. So let's say that this is my sample, and it is 88.8% oxygen and 11.2% hydrogen. Those percentages will stay no matter the sample size. So if I have 50 grams of my sample, 1 gram of my sample, 1,000,000 grams of my sample, still 88.8% will be oxygen and 11.2% will be hydrogen. So if you have to convert it, which we do, the best thing to do is assume 100 grams of sample. That conversion is easy. 11.2% of 100 is 11.2. So 11.2% of hydrogen becomes 11.2 grams of hydrogen. And 88.8% of oxygen becomes 88.8 grams of oxygen. In the next step, we're going to change these grams to moles. The reason why we're doing that is because moles are comparable in an apples to apples sort of way, where grams is not as useful to us to compare one to the other. So we're going to convert both things to moles. Step 2, change each of the grams to moles. That's a single step process because we're just going grams to moles. That's only one box on the mole diagram. So grams of hydrogen will come to the bottom and moles of hydrogen to the top. And in oxygen's equation, same thing, grams of oxygen to the bottom, moles of oxygen to the top. Our next step is to fill in the molar mass, and this is the molar mass of a single hydrogen or a single oxygen. So we're just looking it up on the periodic table. 1 mole of hydrogen is 1.01 grams of hydrogen, and 1 mole of oxygen is 16.00 grams of oxygen. Now we plug this into our calculators to get the answers. 11.2 divided by 1.01 gives me 11.09 moles of hydrogen, and 88.8 divided by 16.00 gives me 5.55 moles of oxygen. Now we have a comparison and we can create a ratio. How much oxygen to how many hydrogens? And so what we're going to do now is we divide by the lowest number of moles. So you're going to look at these two numbers, 11.09 and 5.55, and decide which one is smaller, 5.55. So I'm going to divide them both by 5.55. And when I divide them, I'm going to round. If we're very close to a number, we are just going to let it be that number. So for example, 11.09 divided by 5.55 gives me 1.998. I'm going to go ahead and let that be 2. And 5.55 divided by 5.55, don't even need a calculator, I'm so amazing, is 1. So what has this given me? This has given me subscripts of my substance. So what this is telling me is that my original sample was H, right? This is my hydrogen, H, 2, 1, O, O. So my ratio is 2 to 1 hydrogen to oxygen. And so this is the answer. This is the empirical formula for a substance that is 11.2 hydrogen and 88.8% oxygen. I told you it's like a magic trick, right? We go through this whole process. You go percent to mass, mass to moles, divide by the lowest number of moles, et voila, magic. You end up with the subscripts for your formula, for your substance. We'll try more of these in class on Thursday, but for now, you can try the one on your practice test. Nice work, you guys. We're done with chapter 10 and get yourself ready for the exam. So I'll see you in class.